Okay, in this example, we're going to be graphing the function f of x equals 2 over x plus 1 minus 1. And then we're going to state the domain, range, and describe the transformations for the function. So as we go about this, first of all, to notice that this is a reciprocal function. So we are going to be using transformations here to graph it. So I'm going to use my typical rules I use whenever I do transformations. The inside stuff affects the x values in the opposite way. The stuff underneath the bottom of the fraction would be the inside stuff because that's where x sits in the parent function, 1 over x. So I see an x plus 1, which means it's going to affect the x values, but in the opposite way. So instead of doing x plus 1, I'm going to do x minus 1 to each of my values on the graph. Now I also have some stuff outside. Normally the parent function has a 1 on top. However, we have a 2 on top. So that means we have something connected by multiplication, since that's how the fractions work with multiplication. And this is going to be considered to be outside because it's not down with the x. We also have the minus 1 off to the side. So outside affects y values, but it affects it in the same way. With that, I'm going to have to take my y values, and since it affects it in the same way, that means we also follow order of operations. So we are going to multiply by 2, and then subtract 1. With that, I have my transformation rules that I can use on my order pairs and my starting information. So the parent function 1 over x has some key facts that we can use to help us graph it. For instance, it goes through the points 1, 1 and negative 1, negative 1. We could use other points, but those are probably the easiest ones to use. And it also has asymptotes at x equal to 0 and y equal to 0. And that's what the parent function 1 over x typically has for key information. Now we're going to take each of our values here and we're going to use our rules for the transformations that we just developed. So our first rule is for x. So I'm going to take all my x values and subtract 1. So 1 minus 1 is 0. My second order pair, negative 1 minus 1 is negative 2. And for my asymptote, has a value of 0 for the x asymptote. So it's going to be x equals, subtract 1, negative 1. So I've taken care of all my x stuff. Now I'm going to go back through and take care of my y stuff. So y is a little bit more complicated. We're going to have to multiply by 2 and then subtract 1. So 1 times 2 is 2, minus 1 is 1. Negative 1 times 2 is negative 2, minus 1 is negative 3. And for the asymptote, the y asymptote, 0 times 2 is 0, minus 1 is negative 1. So there is my information that I can use to graph this transformed function. So I'm going to start off by plotting my points, 0, 1, and negative 2, negative 3. We have asymptotes. X equal to negative 1 is a vertical asymptote where all the x values are negative 1. X values are negative 1 right here. So vertical asymptote where all the x values are negative 1. And asymptotes are represented by a dotted line since they are not actually part of the graph. They're just used as reference lines when you're drawing a graph by hand. For the y equal to asymptote, it's a horizontal line where all the y values are negative 1. Again, it's dotted. There we go. And then finally, to draw the graph in, this graph kind of hugs the asymptote, then it will curve through the point, and then hug the asymptote. So it's going to look something like this. And then on top as well, we'll hug the asymptote, curve through the point, and then hug the asymptote. Remember, these graphs don't cross the asymptotes. And that's it for the graphing part. We have two more things that we're supposed to do. We are also supposed to state the domain and range. Well, for reciprocal functions, domain and range is pretty easy. Domain and range, well, the domain is just everywhere the function exists besides the asymptotes. It exists everywhere but where those asymptotes are. So the domain is all real numbers, but x can't be the asymptotes at -1, so -1. And there's a number of ways to actually express this. And range is the same thing. All real numbers except for where the y asymptote is. Y can't be -1. And again, there's a number of ways that I could actually express this. This is just one of the ways. Now we have one more piece that we're supposed to do. We're supposed to also describe the transformations. So what we're going to do when we describe the transformations is we're just going to take our rules here and use them to help us describe them. Well, addition, subtraction, I know creates a translation, so I know this graph is being translated. Since it's x minus 1 is our addition subtraction rule for x, the subtraction for x values will take it in the left direction. So it's going to be translated left 1 unit. We're also adding and subtracting to the y values. We're subtracting 1 to the y values. Well, y is going to be in the up and down direction, and if we subtract 1, it's going to be down 1 unit. We also have another transformation going on. We have times by 2 as well. Multiplication creates a dilation in the graph. So this graph has been dilated. It's vertically by a factor of 2. It's dilated vertically. The vertically part comes from multiplying y. The factor meaning we're multiplying by the specifically 2. You could also be more specific if you wanted to and say that this graph is stretching instead of dilated because we're multiplying by a number bigger than 1, so it's going to actually spread the y values out. And that's out.